Okay, everyone. Basically, just one more rule to show you for how to find derivatives, and then you'll know basically everything there is to know about finding derivatives of any function you'll ever meet. So, as I mentioned in the last lesson, we're going to look today at functions like this: the sine of x. Make it x cubed. That's fine. Sine of x cubed. And this is the composition of functions. Remember, composition, that's where you have one function, which is f of x, say, which is x cubed. And then before you see what comes out, that one goes into another function. G of x is equal to sine of x. And by the time it comes out of this one gives you an x cubed out. Whatever goes into this one takes the sine of it. So you end up with sine of x cubed. So having a function like this is the composition of the sine and x cubed. And the question is, how do we go about finding the derivative of such a thing? So here's the answer. And again, I'm just going to give you a rough proof of this because it's short enough and it just kind of helps motivate the answer. So here's what we have. We're going to call it f of g of x. And basically, we want the derivative of that thing. I'm going to write it like this: the derivative of f of g of x. And so recall that by definition, this is the limit as t approaches x of f of g of t minus f of g of x all over t minus x. By definition, that's the derivative of this function. Don't worry if you don't follow this. Just appreciate that someone has thought this through. It just takes a minute. And again, we're looking for another trick. And in the last problem, we added and subtracted the same thing. So we added 0. Here we're going to go back to what we did when we looked at some limits. We're going to multiply and divide by the same thing. So here's what I'm going to write. I'm going to write the limit as t approaches x of f of g of t minus f of g of x divided by g of t minus g of x. And I'm going to multiply that by g of t minus g of x all over t minus x. So notice I just multiplied and divided by the same thing. So if I were to cancel those out, I'd get the same thing here. And this thing, again, I'm not going through all the details, but this is the idea that basically, if you look at what's happening here, I have f of something minus f of something here divided by those two things. This is the way. Let's write this one out first. This is g of t minus g of x all over t minus x as t approaches x. So this thing right here is the derivative of g at x, right there. That's the derivative of g at x. G of t minus g of x over t minus x. The change in the y values over the change in the x values. This is the same thing essentially because I got f of something here minus f of something else here, and whatever these two things are, you find them downstairs. These two things, you find them downstairs. So it's the derivative of f evaluated not at x like this one was, but evaluated at g of x is really what you've got there. So you've got f prime of g of x, this thing is, times g prime of x. And that's the answer. Let me write it right here. F prime of g of x times g prime of x. Like that. And so there's the answer. And it looks much more complicated than it is. It's really not all that hard. Here's what you do. So going back to the one we have up here, we have f prime of x. This thing right here, what does this say to do? it says you work from the outside in. See, this is the outside function here, and here sine of x is the outside function. You take the derivative of the outside function and you leave the inside function alone. So the derivative of the sine is the cosine. You leave the inside alone. Don't touch it. Don't touch it. Leave it all alone. And now you can turn your attention to the inside function. What do? You just multiply by the derivative of the inside function. The derivative of x cubed is, of course, 3x squared. So you could leave it like that. I typically like to put the x squared in front just so that it's super clear what you're taking the cosine of. Like that. So there's the answer. That's all there is to the chain rule. So we'll do a bunch of those just to make sure you have them solid, because it's one of the ones that just takes a little getting used to. Let's try, we'll just put them right underneath each other. Here's g of x, let's call it, I don't care. Let's let it be the square root of x squared plus 7. Okay, so one way of, way of writing that is x squared plus 7 all to the 1/2 power. So, what would the derivative be? This is the inside function. This is what you would do first to x. And this is the outside function. That's what you do later. So this is the outside, this is the inside. So again, what do? You start from the outside working in. What's the derivative of anything to the 1/2 power? Don't worry about what this looks like. It's just think of it as a great big x. X to the 1/2 power, its derivative is going to be 1/2 of that thing. Don't touch it. Leave it alone. All to the negative 1/2 power. See, that's what it says to do. You leave the inside one alone. You just pretend that you're looking at the outside one. And now you multiply it by the derivative of the inside. Derivative of this is 2x. Derivative of 7 is just 0. So you get that. Then again, you can do some canceling there. And you can write it as x over the square root of x squared plus 7. That's the idea. Okay, let's do several more. By the way, this is called the chain rule. And you can kind of see why, because you're kind of forming a chain. You multiply these various derivatives together. They're all multiplied, so it just kind of forms a chain of derivatives. So let's try another one. How about f of x is equal to the ln of, let's make it tougher, of cosine of x cubed plus x. Okay, there we go. This one has 3 levels. If you were to evaluate this, you'd first do this to it in either order, just those 2 things. Then you'd take the cosine of it, and then you take the ln of it. So first level, second level, third level. So you work from the outside in. So what do? The derivative of the ln of anything, don't worry what that looks like. The derivative of the ln of anything is 1 over that thing. Now we turn our attention to this thing. And what do? We want the derivative of the inside. Well, look at here. I'm going to have to use the chain rule to take the derivative of this. What's the derivative of the cosine of anything? It's the negative sine. So write negative sine of that thing. Again, don't touch that thing. It stays as is. And now, finally, times the derivative of the inside, which is what? 3x squared plus 1. Does that look good to you? It's 1 over this times the derivative of this, which is this, times the derivative of this, which is this. Look good? If it does, you're missing something. You have to multiply the whole derivative by this thing, and what I have here, you would multiply it just by this, but you would add 1 after doing that multiplication. I want this whole thing being multiplied by that, so I need parentheses there. Okay, and then there's no reason to have a negative here. Might as well bring it out front like that. So that's the idea. Okay, let's try another one. This next one, I remember, confused me, mainly because it's just so easy. Let's try this one. F of x is equal to e to the x to the fifth plus sine of x. Okay? E to that. What's the derivative? So this is what you would do first in either order. Those are all at the same level because you're adding them together. So that's the first level. And then once you evaluate that, then you would take e to that. So that this is the second level. So you work from the outside in. What's the derivative of e to anything? Derivative of e to anything is just e to that thing. So don't change it at all. There. I've just taken the derivative of this thing. Okay, the derivative of e to the x is e to the x. So there's my big old x there. Now, what do? Now I multiply by the derivative of this thing. Derivative of this thing is 5x to the fourth plus what? Cosine of x. There you go. And again, make sure you have your parentheses there because this whole thing has to be multiplied by that. Okay? Let's try another one. You just, again, you want to do a lot of these so that this is the kind of the technical, what's the word? Just mechanical part of calculus that you just want to get down solid so that once we get into the interesting problems that will come up later, then you can use all these things without having to think about them. So how about this? F of x is equal to sine to the fifth power of 5x squared plus 7x plus 10. Okay? Well, notice that this one has three levels. You would first do this, then you would take the sine of it, and after taking the sine of it, then you would take that all to the fifth power. So what I would suggest with one like this is, while you're learning, just rewrite it to look like this, just to really demonstrate to yourself that this is the first level, then you're taking the sine of it, and then you're taking that to the fifth power. That makes it easier to see what the derivative is. You have something to the fifth power. What's the derivative of anything to the fifth power? It's going to be 5 times that thing, don't change it, all that to the fourth power. Now I took care of this one. Now I multiply by the derivative of the thing inside. What's the derivative of the sine? Derivative of the sine of anything is the cosine of that thing. And now you have to multiply that by the derivative of the thing inside that yet, which is what? Derivative of this is going to be 10x plus 7. So there you go. So that's the idea, okay? That's how you use the chain rule. And the other thing I want to do in this lesson is to show you how the chain rule allows us to find just a couple more derivatives that we haven't done yet. Let's do this one first. What is the derivative of the arctangent of x? Recall what the arctangent looks like. Here's the tangent, it looks like this, and the arctangent is what you get by flipping it over. It looks like this. So it has kind of, looks like a medium slope right there, and then as you go out farther and farther, the slope settles down. It looks like the slope is always going to be a positive number. You're always going uphill there. But what's the formula for the derivative? Here's how you can get it. Watch this, it's kind of clever. We start off by saying that I know that the tangent of the arctangent of x is just equal to x. They're inverse functions, they undo each other, and so if you take the tangent of the arctangent of x, you just get x back again. So now we're going to take the derivative of both sides. what's the derivative of this side? Recall that the derivative of the tangent is 1 over the cosine squared. So the derivative of the tangent of anything is 1 over the cosine squared. So when I take the derivative, okay, I'm going to take the derivative of both sides, and I'm going to get 1 over the cosine squared of the arctan of x. Okay, that took care of the tangent. Now I have to multiply that by the derivative of the inside. Well, that's what I don't know. So I guess I just have to I just write down times the derivative of the inside. Okay, there it is. I don't know what it is yet, but that's certainly true. The derivative of this thing is 1 over the cosine squared of this times the derivative of the inside, and that's all going to be equal to the derivative of x, which is just equal to 1. So now I can bring this, multiply both sides by this, and I get the derivative of the arctan of x is equal to cosine squared of the cosine squared of the arctan of x. Okay, so the derivative of the arctan is equal to the cosine squared of the arctan. Well, heck, I know what the arctan looks like. That's easy enough. But you asked me to graph the cosine squared of the arctan, and I have no idea what that looks like. That's beyond comprehension. That's the bad news. The good news is we can find a way to make this into something which is much easier to understand. And here's the trick. This is something I didn't show you back in the trig section, but I can show you right now. Recall what the arctangent is. It's the angle whose tangent is x. So all we do is we draw ourselves an angle whose tangent is x. Okay, there's the angle right there. If I want to, I can think of that as being arctan of x. It's the angle whose tangent is x. What's the easiest way to make an angle whose tangent is x? Tangent is the sine over the cosine, so x over 1 would do it. And so there's an angle whose tangent is x right there, x over 1. And then it says it wants the cosine of that angle. Well, the cosine of this angle is this divided by this. I don't know what this is yet, though. Oh, but I can figure it out easily from Pythagorean's theorem. Whatever this is, let's just call it c for the moment. C squared is equal to 1 squared plus x squared. So c is equal to the square root of x squared plus 1. So this right here is the square root of x squared plus 1. So what do I know? The cosine of this angle is this over this. Let's write that down. The cosine is 1 over the square root of x squared plus 1. And I don't want the cosine, I want the cosine squared. So I square that whole thing, and it makes it even nicer than it was before. It's just going to be 1 over x squared plus 1. How cool is that? So the derivative of this function is 1 over x squared plus 1. Okay, some of this stuff, it's not, I show it to you, it's kind of cool just to see where it comes from. The most important thing is to know this result, because you will use this result from time to time in calculus. Okay, let's see that that makes sense now that we have the formula for it. Here again is what the arctan looks like. Looks like that. What does this say? It says when x is 0, 1 over 0 squared plus 1 is 1. 1 over 1 is 1, so it says the slope is 1 right there. And then as x gets bigger, what happens as x gets bigger? This is going to get smaller and smaller, get closer and closer to 0. Sure enough, it looks like that gets closer and closer to 0. Recall that this approaches pi over 2, negative pi over 2. Okay? Notice that this is always a positive quantity, which makes sense because it looks like no matter where you check the slope out, anywhere along there, the slope is always going to be positive. Notice that this is an even function, which makes sense. It looks like the slope right here is the same as the slope right there. So those slopes are the same. The arctangent itself is an odd function, but the derivative of the arctangent is an even function. Okay, that's not just a fluke, that's always the case. The derivative of an odd function is even, derivative of an even function is odd. Okay, so there's the arctan. Let's just do the last one. So what is the derivative of the arcsine of x? This one is the more important. That's why I did that one first. And so here we go. We're going to do it the same way we did the previous one. We're going to start off by saying the sine of the arcsine of x is equal to x. Okay, they undo each other. Now I take the derivative of both sides. What's the derivative of the sine of anything? The derivative of the sine is the cosine of that thing, times the derivative of the inside so there's the derivative of the left-hand side. Now what's the derivative of x? That's just 1. So now I can solve for this again, and I get the derivative of the arcsine of x is equal to 1 over the cosine of the arcsine of x. Okay, so let's do the same thing as we did before. This time I'll just put it in a unit circle. Let's think of it like this. So here you have yourself an angle. There's the angle whose sine is x. What's the easiest way to make an angle whose sine is x? Sine is this over this. Cosine is this over this, and tangent, of course, is this over this. We want the sine, so we want this over the s. So for the sine to be x, we can make this be x and this be 1. There's an angle whose sine is x. Now that I have that, I want the cosine of that angle. What's the cosine of this angle? Cosine is this over this. Dang it, I need to know what this length is. Let's solve for it. Using Pythagorean's theorem, b squared plus x squared is equal to 1 squared. B squared is equal to 1 minus x squared. B is equal to the square root of 1 minus x squared. So there's b. And now the cosine, what did we say the cosine was? Cosine is this over this. So this now is equal to 1 over, the cosine is this over this, which of course is just, you don't need that 1 there, you can leave it just like that. So there it is right there. So there is the derivative of the arcsine. Like so. So that's basically all the derivatives you need for calculus. And you can get everything you'll need, you can get from those. Not likely, but it's possible that you might be asked sometime or want to know sometime, what's the derivative of this function? Let's say e to the x. Let's just say e to the x. E to the x. Let's just leave it e to the x. Okay? Well, what's the derivative of it? Well, what does it say? You have to work from the outside in. So what's the derivative of the arctangent of anything? The derivative of the arctangent of anything is 1 over whatever is there. You don't touch it, you just square it. So this thing squared, if I take e to the x and square it, it's going to be e to the 2x, and then add 1 to it. So there's what I get by taking the derivative of the arctan of e to the x, and now I have to multiply it by the derivative, let's see, I'm sorry, here, by the derivative of the inside. What's the derivative of e to the x? It's just e to the x. So you can just multiply it by e to the x like that. Okay? Let's try one more, just for practice. Suppose you want the derivative of the arcsine of x to the fifth. Okay, what would that be? Well, the derivative of the arcsine of anything, what do? You first, whatever this is, you go 1 over the square root of 1 minus whatever this thing is, you square it. So here I have that thing, so I square that. X to the fifth squared is x to the 10th. So I get that. Now that I'm done with the outside, now I ask, what's the derivative of the inside? That's obviously 5x to the 4th. So you multiply it by that, and you're done. Very good. So that's called the chain rule, and we'll go from here. But you're getting all the mechanics you need to solve almost any calculus problem at this point. That's it.